Okay, I have a question for you up front. So who saw the room talk before? Okay, yeah, that's what I thought, because when I pitched my talk, I wasn't aware that room also has its own talk. So I tried to shorten it a bit, but cover really the most important or interesting aspects of room. All right, let's get started. So when you look at the mobile world, it's mostly SQL, but SQL came initially like from the server. It has its history from Oracle and IBM, like the real big companies. Oh, sorry, that was the wrong one. Okay. And also SQLite, the database you have on Android and iOS, it is around since 2000. And it's the most used database. Like each on your desktop computer, it is running at least with like 20 instances, whatever. So it's very, very popular. And of course, you still have SQL rows and columns. And this doesn't always nicely fit with the object world, right? So that's why there are ORMs, object relational mappers. Also, those come from the server space. So personally, I was doing a lot of Java Enterprise stuff before doing Android, and like things like Hibernate. Always like I thought it's so cool to have that, not to work with SQL anymore. So how does a ORM work? So basically, it's like the mediator, like the bridge between both worlds, right? And it gives you a higher level of abstraction. So you can work with objects, and you have to do less SQL. So it also helps you with queries and so on. Right. So this is where we come from, and now this year at I/O, Room was introduced from Google, and the most three important classes you have to know in Room are those. So there's a database. That's how that's like your initial access, kind of. You have to, you get a builder, and you can also do migrations and get DAOs. Like we come to DAOs in a second. So, and then there's entities. Entities are the objects that you can persist and load. And the good old DAOs. So these are like the data access objects. So how you interact with the concrete type of class. And a very interesting aspect of Room is it's basically bring your own API. That means like the API is not that fixed. So for example, if you look at a database class, you will provide an abstract class, and Room will extend it and implement like the abstract methods. This looks like this. And also for DAOs, it's similar. You provide some interfaces. So who's using Retrofit? Maybe hands up. Yeah, you know this approach. It also works with Room. So how does this look in code? So this is how you initialize your database. In here, you can provide your own methods to get a DAO, so you can play around with the DAO later. And to initialize that, like that my RoomDB, you go through room.databasebuilder and provide an Android context and like the class here and the name for your database file. And also you can add migrations, and when you build it, and then you have your database. So remember, those database classes give you access to individual DAOs, and DAOs are interfaces again. You just use a tiny annotation DAO, and then also for if you want to insert an object or retrieve or update it, delete it, there are annotations for this. And in the end, it looks like this. So this is what you write, and Room will give you the implementation. So, how about queries? So this is where Room really embraces SQL. It doesn't want to hide SQL from you. It rather encourages you to use SQL, and that's how you work. So you also, like, if I may go back one slide, where's this DAO? And in this DAO, you can also have like query methods. So you do another annotation, query, and in a simple way, like just to get all users, you would select star from users, easy. And also Room is intelligent kind of to map those parameters that you have in your method with the SQL you give here. So this is really a really nice way of doing things. However, Room does not support relations. That's not a coincidence. There's a whole paragraph on the Room documentation page for arguments not doing it. So it's kind of similar to SQL Delight. They also say, we don't want to be even an ORM. We think like the whole relation thing, like relational and object is just broken, so we don't touch it. And a similar way is for Room. So one of the problems with relations is that when you get an object and that has like relations, it's usually lazy loaded relations. That means when you get your query result back and you hit like get address whatever from a user object. So at that point in time, the user may have some delays because there will be a data query being made. And if you scroll in a list, so for each display item, you may have a new query running in the background. So this is the problematic field. And Room ways of doing it is have like objects, like classes that are really tailored to your UI. What are maybe the 5 fields that you display? Just select those. So it will be like a SQL select with joins, just to get all the data you need for what you want to display. Okay, I think that's it for Room. If there are questions about Room, we can, I guess we should do it at the end, or do you want to go ahead? That's fine, huh? All right, but still it's SQL. So you really have to know SQL kind of. So on Sunday we had a barcamp discussion, and I just want to have 2 quotes, not from me. So SQL is really easy to get started, but hard to master. And this in combination with this quote. So when you use an ORM, you cannot shy away from SQL, because at some time, unless you're doing a really simple app, it will hit you. So we shared 2 quotes from that discussion, and I kind of liked it, because that's what you have to do. Either you embrace SQL and really learn it, or try something else. Which brings us to ObjectBox. Okay, so what is ObjectBox? So I did Green DAO before, back in 2011, and I always wanted it to be like the fastest ORM, and so I kept optimizing. But at some point in time, I just realized I could only go this far, because then all like performance is wasted in system APIs and SQLite. So some years later, I thought, okay, so we really have to get rid of SQLite and just make everything in a way that works nicely with objects. Yeah. And it really, yeah. So one thing that is really important, I think, for object databases is to figure out relations. So in Green DAO, it was always like, we could do it this way, but it didn't really never work. And it's a common problem with ORMs, like lazy loading and so on. It's always a pain. So in ObjectBox, it's very efficient to resolve relations, and also it supports lazy and eager loading. Yeah, and yeah, I'm a performance guy. I always want to have my libraries very, very fast, so it's very optimized for performance. And there's an open source app just to check out the performance, so you can have a look at the code. So again, so when I built ObjectBox, it was 100% clear that I should do as less Java as possible, because Java on Android is still very slow. On like the desktop, it is sometimes really as fast as C++, but on Android, not yet. That may never be the case. So one goal is to do as much as possible in C++. And also, like, keep it really simple, because but actually it's like the same thing. If you do it really simple, it will be always so fast. So kind of same argument. Right, let's look at the API a bit. So where's this concept of a box? And you just put objects in a box. So it's very easy, right? And for each type, there's a different box. So you get a box object for example, like a address or a person, and that's the way it works. And there's also like a box store where you get a box from. So you just say literally like store box for and this class, and you have it. So that's how you like insert a new node. So it looks for Realm or AMS, it pretty much looks the same to API, right? You have an object and you do something with it. So yeah, and there's also some other methods, obviously, like get all. So ObjectBox, like most ORMs and Realm, come with a fixed API. So you don't need to have define an interface for that, right? You just say get all, and you get all nodes. And yeah, so we try to make things simple. So if you have like 2 nodes, you can just comma separate them, or just pass a list. Same for put. Where's count? And of course, there are queries. So queries are done with Query Builder. And you can have several conditions, like for example, equal or starts with. And once you have a query, you can run it. You can say, I just want the first, or I want all. OK, let's check out entities. So an entity is actually like a plain old Java object. So once you have the object, it has all its properties filled. There are no threading constraints whatsoever. And yeah, so this kind of simplifies some things. So you have seen before, like there's this put command. And on the other hand, there's like, if you think SQL, there are a lot of different ways to insert, update, update or insert. There are lots of different ways how to do this. In ObjectBox, there's just put. And it is like the semantics, what it does, if there's an ID 0, then it's a new object. And if it already has an ID, it's going to be an update. And for example, you can like put a list, and it doesn't even matter if it's new objects or old objects. You can just put it in a list and store it as it is. So this is like in relation example. So this is like a one-to-many relation. And so for the to one side, you need to have a little proxy class here. But that's all you have to write. You don't even have to equals new or whatever. You do not initiate this. So this is done by ObjectBox. So how this works, it is like your class will be modified at build time a bit, but you won't notice. And like one order belongs to a customer, right? But a customer can have a lot of orders. So this is the backlink. That's why you put a backlink. And it, because there's just a single link in this direction, it knows, okay, it must be this guy. So this ensures it's the same data. So this is a real one-to-many relation. And yeah, so you can use just list of an entity, and this will make up your relation. So how does it look like if you want to insert a new entity? So we have a playlist, and we add 2 songs to it. This is the Java code. Just to initiate the Java side of things, and to persist all this, you need this. So this persists, the single put will persist your playlist and the 2 songs that are attached to it. So yeah, if you want to do this in SQLite or even in Room, I think that's going to be like, I don't know, small. Queries again. So who knows JPA, by the way? Okay. So in JPA, there's a concept of meta classes. For each entity, you will have some meta information stored in a class with underscore. And the same is true for ObjectBox. So for each entity you can have a safe way to access properties and relation. So you will see in the query example right now. Yeah, I think I talked about the query builder. And yeah, okay. And in queries you also have aggregates. So you can have like what is the highest volume or whatever. So here again, a more complicated example for a query. So it always starts with the box. The box is really the central part you have to work with. And you say query, and here are those meta information classes, right? So there's no way you can have a typo, so this is checked at compile time. Okay. I'm just wondering. Right, there's another nice thing about ObjectBox that relates to testing. So usually when you test your database, you have to make an instrumentation test on Android. So you have to deploy your app on device and run the test here. And this is very slow. Whereas, at least for SQLite, you can do this with Roboelectric, but it's still like until Roboelectric boots up, that's kind of slow. And with ObjectBox, it allows you to run real Java unit tests because ObjectBox also runs on a desktop. So this is really, really fast. I think I can show this maybe. Wait a sec. Okay, if Windows lets me. No, apparently not. No, okay, sorry. So we use the same for unit tests, for unit testing ObjectBox, and it runs like, I don't know, like 100 unit tests in like 2 seconds or something. All right, so when you deploy your app, it probably won't be the last version. You probably will have new entities and new properties. So that is like so this is going into the direction of migrations. And ObjectBox has a like a meta model of all entities and properties to track IDs. This will in this way it will like if you have several devices, it can address always the same entities and properties internally. This is some information you might need later on, because if you add a property, it just works. You just add it to your class, and you don't have to do any migration or migration scripts. Same for removing. If you rename something, then you would have to have his UID annotation that we have, and this will reference one of those IDs I was talking before. So once you put this UID to this entity or property, you can rename it any way you want. You can refactor it. ObjectBox will always keep track of that. So that's a totally different approach to migration, and we really want to make this very simple. I think at this point, we are not quite there yet, but yeah, I think we're on a good way. Let us know. Anybody use GreenDAO? Hands up. Okay. So there's also like a little compatibility layer for GreenDAO. That is like a GreenDAO API on top of ObjectBox. And it emulates the GreenDAO API, and it helps if you have an app with GreenDAO to switch to ObjectBox. Yeah, or you could also use it in combination for, yeah, but okay, forget about this option. It doesn't make sense. All right, so yeah, ObjectBox was released yesterday in version 1.0. Woo! And yeah, we're still at the very beginning and just would love your feedback. So I hope you have some time trying it out, giving it a shot, and writing us emails how you like it or what you don't like about it. Really want to make this good. Okay, so how many of you like SQL? Hands up. Don't be shy. Okay, not so many. So it's a kind of scale on how much you want to be on the SQL side or on the object side. And for example, if you do SQLite Android APIs, you have a little abstraction already, kind of, but you're still very much into SQL, right? The next closest thing would be something like SQLite, where you still have your you basically create table statements that gets translated into Java classes. And when you have room, where you have Java classes, but you have all your queries in SQL. And like typical ORMs they would try to hide most of SQL away. And yeah, on the other spectrum, there's like ObjectBox and Realm, and yeah. So that's kind of the choice you have to make. So how much SQL do you want in your app? Kind of. Okay. Oh yeah, we also have some benchmarking. Actually, we have an open source project. So on GitHub, just GitHub/ObjectBox, and then you see a couple of repositories. And one of them is like just for benchmarking. So please check our code. Don't trust any benchmark code that you don't have access to. So we really encourage you to look at it. And yeah, so these are our results. And because we're totally dropping this rows and columns approach, it's more like a key object database kind of, and key value databases, like if you know SQL and NoSQL in Java world, in enterprise world, it's like the fastest databases you can get. So with no SQL approach, bringing this to mobile is just giving you so much more performance. Okay, also for queries, it is very fast. You can do a lot of more queries, and especially like this one is very important because this is how you resolve relations. And if you can do a lot of them, that's pretty good. So maybe it doesn't even matter if you have like lazy loaded relations, because ObjectBox does this just so much more efficiently. Oh, by the way, I totally missed. There are also eager-loaded relations. So for each query, you can just say eager and list your relations that you want to have preloaded, like in a background thread. And this way, you can have like the entire object graph that you need in your UI thread without doing anything that has to do with the database. So this is all cached. Okay, I think that's it. Thank you. Questions? I think there's a microphone. Yes.
Hi there, that looks very promising to me. Is there any chance for any iOS counterpart for this one?
iOS, that's something in the queue. We cannot tell any time frames for that.
So not yet for
yeah,
now.
so we are like Android first, and yeah, let's see.
Okay, thanks.
So you didn't really answer the question from the Barcamp, I think. So
what was the question?
Will SQL hit me if I don't care about SQL?
Again, will SQL hit me?
No, sorry. Yeah, just how much do I need? Do I need to still care about my data? How much do I? Well, it will not be SQL because you're no SQL. But how much do I still need to think about my data?
I would say think about your objects and your classes, and you're pretty much done. As simple as that.
Just a little question. If I have a relationship like that customer and order that you showed on your slides, and I navigate in my Java code from the customer to his orders and back and forth and back and forth, do I get identical objects every time, or new instances but equal?
In that case, you get new instances all the time.
Okay,
so it's a little different from Green DAO. There was like this ID session thing, whatever. But here you always get like fresh objects out of the database.
I wonder, the better performance you achieve, is it because you somehow optimize I/O operations, or is it because you do some clever caching and do operations asynchronously? And another question is, I think I'm definitely not an expert in this area, but I imagine that the performance of such systems is very much media and file system dependent. So I also imagine that for SQLite, some optimizations has to be made by the vendors. Do you also take something of this kind into considerations, like not creating big files and reading, chunks and some kind of this type of implementations? Because you are dealing with flash memory in the end, right?
Yeah. So there is absolutely no caching. It is the really like the objective was really to make it all to the minimum. So in the end, it comes down to like memory mapped files and how you store objects in those, like really in a binary format. And so, yeah, so the main bottleneck is actually Java and JNI. There's also a C++ API for ObjectBox. It's not available at this time, but we have that, and it's like, if you think that is fast, the C++ one is really fast.
But you store the data persistently.
Yeah, sure.
And you don't use SQLite to do that.
No.
So you have your own
Yes.
proprietary implementation, which is
Yeah,
open
yeah.
source.
I'll answer your question. So, like the Java part that you interact with, that is open source, then we have a closed core for like the real database engine stuff, but it's always going to be free. And we're thinking about right now how we're going to approach this further in the future. Usually Java developers don't care so much about C++ code, but yeah. And with I/O in general, it's, yeah. Like this kind of secret is really memory mapped files because they're so blazingly fast and they do so much caching for you. It's something in your Linux kernel. Yeah, hope that, maybe we can have a talk one-on-one.
Yeah, sure. Thank you. Yeah.
Okay.
Cool.
Hi, thanks for the talk. I have a question. In our app, we need to sometimes refresh the data for our objects over the internet. Would that be possible with ObjectBox? So freshly loaded objects from internet don't have internal IDs from the ObjectBox database. How would you map those objects to the persistent objects?
So in that case, you would have like a secondary ID, and you would have to do some manual work. So ObjectBox, one of the early on design decisions was to go with long IDs, also for performance reasons. And at some point, we will also have string IDs, but not in 1.0.
Okay, thank you.
Hi. Is there any form of rollback system? Let's consider you have like a really huge list of like 1 million objects, and you want to insert them into your database, and then the app crashes like in between. And is there like anything like a transaction?
Yeah. So there are transactions. It's actually ACID, atomic, isolated, durable, whatever, consistent. So yeah, your data is should be pretty stable. So even if your app goes, or if you take out a battery in your phone, from your phone, you should have like a committed state still.
So what's the default behavior when you're inserting, when it crashes halfway through? So will it not save anything, or will it save just the half? And
No. It's like really. For example, you say put list of users, okay? So what will happen, there's an implicit transaction for those users, for this list of users. So if your app crashes in the middle, it looks like you didn't even start with it. So you really have a committed state. So this transactions are about all or nothing. And if they break in the middle, you have nothing of this transaction.
Thank you.
Thanks for your talk. I have a question regarding the C++ API. So we just took our business logic and implemented it all in C++ and have it shared across Android and iOS. We made it with SQLite, and we found out there's not much to have library-wise so far. So the question is, did you think about making it portable to iOS, so that it can run both on Android and iOS and can be used via C++ API? Because I think there's...
So the thing is, the C++ stuff is cross-platform. Also, our Java ObjectBox runs on a desktop, right? So that means with Java, on the one hand, it runs on Linux, macOS, Windows, and same is for the C++ API. But the API, that would be like you would have to contact us and work with us a little more one-on-one. So there's no public thing here.
That sounds very, very promising.
Okay, thank you. Okay, more questions? All right. So thanks a lot.